Our presenter is Tony Salas from Powertrain Training, and the title to Tony's presentation this morning is the part two of our December webinar, which was on the subject of the Duramax LP5. So this time, it's my pleasure to introduce Tony Salas. Take it away, Tony.
Thank you. And once again, as you can tell, Mr. David is not feeling under the weather. So we thank him for taking the time here since he should be in bed, feeling better. But definitely hope, once again, David, hope you feel a lot better.
Thanks, Tony.
We're going to be talking about the L5P Duramax. Hopefully my screen is showing up there, the title screen. And in this case, well, welcome everybody. Definitely happy to see everybody. Um, well, it is today been, like I said, I've been taking a few phone calls and stuff and working on a few trucks. If you have not seen, first of all, let's get one thing clear. If you have not seen the part one, it is available from Lucas on their page. And in this case, they do have a YouTube page. And you're going to see all the recordings that they've done, not only by me, but others as well. So in this case, if you need that info, you can ask us towards the end, and I'll have David give you a link to that if that's possible. So definitely want to see, and the previous, pretty much the previous presentations that we've done here for Lucas last year. So therefore, they're all up in there. So there you go. L5P. Well, let's get into that. Just a quick review in terms of, I guess our main focus here is going to be covering some basic stuff here, but also the advanced stuff as well. So if you're familiar with the L5P, it is the Duramax since 2017 and newer, found on pretty much the Chevrolet GMC and also your medium duty internationals as well. So, you know, definitely have that, but they call it the L5D. So there's the L5P and then the L5D. So therefore that is the medium duty option that's available. A few differences between it. So therefore there you go. As time is evolving, okay? A lot of you have not listened and not going to listen. I don't know what's going to happen, but in this case, you know, we have to understand that your knowledge is power and things are evolving dramatically from the EV, what's going on with electrical, and also what's going on today's vehicles. And when I say about today's vehicles, we're talking about pretty much what technology is going to. So right off the bat, I decided to pull up the network here for the L5P. And we're going to notice as I zoom up in here, you're going to see our data link connector. And for those of you who have been taking training or know your training or taking with anybody, we understand pin 16 has always been power and 4 and 5 have been your grounds. But here what we're looking at is the low speed CAN communication. So in this case, when I look at my low speed CAN communication, what I'm going to find here is on pin number 1, because those of you who don't know, there's low speed, medium speed, and high speed. So in this case, as we look at pin number 1 of our diagnostic link connector, we're going to see this JX2000, which I still call splice packs for the longest time that GM has been calling it. But in this case, what you're going to see again is that pin number 1 is headed towards, again, a splice pack where we see an array of different modules, which brings us to K56, which is the serial data gateway module. So the other thing you're going to see that GM has evolved to, if you haven't noticed for a while now, is that you're going to see what we saw, a alphanumerical code for everything or every component. For example, the serial gateway module, like I just said, is K56. The data link connector is X84, and the HVAC control module is K33. The fuse box is X51L. So you're seeing a trend here. If you've been working on European vehicles, you probably have seen this kind of thing where they give you a number of the component and then give you a legend at the bottom. So we got a funny feeling GM might be migrating to that because we see this trend already. Haven't gotten an official word on that, but it seems to be going that way. But the moral of the story is here is that as we look at the data link connector, one of the key players you're going to see is the serial gateway modules. It's something we're going to be discussing more in the future, and also as I play with them as well, because you guys all know that I work on them as well. So therefore, we see a splice pack here, which goes to other splice packs, which goes to other modules. But again, low speed for the most part has been known to be single wire communication. And that's what we see here. So there you go. Now, as we continue looking here, let me skip, well, there's a blow up at the same thing. You're going to see the rest of the other modules that are on that separate splice pack right here. So in this case, we see K9, the body control module, K182, parking assist control module, and again, your seat memory module, and so on. So in this case, depending what options are on the truck based on these boxes right here. So I guess what I'm trying to say is that I am astonished by how many guys that I've talked to or worked with or done training with that have no clue how to read a wiring diagram. So it's something that we definitely have to master here as you continue working on these trucks, you know. So when we look at the overall high-speed side, here's the whole picture right here from the service manual. Now, in this case, you're going to see pretty much two separate, it looks like two separate circuits in reality. First of all, let's find the point of origin, and I like to start off the data link connector. So in this case, we see, hopefully it's a little clear, it's a little fuzzy here, but in this case, there's pin 6 and 14. So for the longest time, CAN communication, CAN, also known as GM LAN, has also been used off of 6 and 14, two-wire communication. So we'll notice right here through these, what I call, once again, these junction points, or junction 211, 212, which once again I like to call connectors. But in this case, you're going to see the symbol right here, also symbolizing that these wires are all a twisted pair. So let's go to the far right here. We'll follow these two wires come here, and you're going to see there's that serial gateway module. So in this case, the serial gateway module is attached, but you'll notice again, you got two wires coming in and two wires coming out, and that is continuing on to the body control module. Then it does pretty much a right turn. It goes over to the power steering control module, if so equipped, and an EBCM, which is ABS, and our chassis module control assembly, and finally to a terminating resistor right here. Okay, so therefore it's not a module. We see a terminating resistor hooked up here. Again, that's one side of the CAN. Then when we look at the other side of the CAN communication, as we follow down here, we're going to see again a junction block, which is part of the instrument panel as well, our transfer case control module, and then we see another X61A. And you'll notice these two should be, let's see, X61A, X61 here. Again, it goes back out to the instrument panel cluster again. So that's pretty interesting on circles. Did you notice that? In this case, we see again X61A right here, then on to the transfer case control module. So obviously it's bypass if it's probably a two-wheel drive. But anyways, we see also another junction block, like I just mentioned. Then it makes a turn, where we go to glow plug control module, and then on to the power takeoff module, PTO, if so equipped. And then at that point, the transmission control module and the engine control module, where finally we arrive there with the terminating resistor inside of that engine control module. So I guess what I'm trying to get across here is, you know, when you're doing communication issues, because I already ran into one guy asking me questions about this, and in this case, we got to understand how to read these networks. Now, I did have a Network 101 class where I covered the basics about this, so you're welcome to view that too again. But I guess what I'm trying to say is when you're programming these different modules, for example, if you do a glow plug control module, like I mentioned in the past, you're going to find out that it may ask you to update the TCM along with the ECM. So if not, you can have issues with programming. So in other words, one is behind the other. So with that said, it may require more than one module to be programmed. Interesting there. So yeah. Now, when you look at internal CAN communication, this is what is the new name that I've heard being used, and I guess it does make sense. This is where you're going to have some interesting issues. In the past, in our drivability roundtables, we've discussed about how we could see a sensor actually drop out and take out the network, but now they're internal, a lot of them. Now, let's pay attention here to this network right here. Now, this is what we call internal. Now, let me start backwards here. Actually, it's not backwards, it's forward in reality. There's my ECM right there, okay? So off the ECM, we're going to see a separate network which goes to the turbo vane position sensor on this truck, then the reductant control module, and then on over to the NOx sensor. So there's NOx sensor 1. So this big line box is actually your NOx sensor 1. And then we see these two CAN wires or GM LAN wires coming in, and then we see them exit where it goes to the particulate matter sensor, and then on to NOx sensor, excuse me, NOx sensor 2, and then finally over to the fuel pump driver control module. So that is where you're terminating resistor. So what I didn't talk about last time I did this class is this internal, again, circuitry, or shall I say network, that you find inside of the ECM. So once again, you got your turbo vane position sensor, you got your reductant control module, and then you got your NOx sensor. So NOx sensor 1 is a big player, isn't it? And then you see it go over to the particulate matter sensor, NOx sensor 2, and finally, once again, to the fuel pump driver control module. So if you really understand or have seen the truck, those NOx sensors, one's located at the engine compartment, and NOx sensor 2 is after the after treatment, which is about mid-bay of the exhaust. And then you got your fuel pump driver module, which is right around the spare tire. So in this case, these wires are susceptible again to damage or issues that can occur. So therefore, can we see, for example, let's say we have an issue in NOx sensor 2 between the NOx sensor 2 and the fuel pump driver module. Can that actually shut down this network among all these? So not only will I have fuel pump driver control U codes along with NOx sensor codes, exhaust particulate matter codes, and the list goes on, such as the reductant control module and also the turbocharger vane position sensor actuator. So yeah, a lot that can happen. So yeah, the reason why I'm talking about this is because you're going to see, for example, the NOx sensors, which everybody struggles with, and believe me, I struggle with them too, is that NOx sensors are now part of the CAN network. So therefore, what we have seen in the past in multiple, not just General Motors vehicles, Ram, Cummins, and Power Strokes, we have seen issues where it drops the network down. So I know this is an internal network, but it can actually shut down communication and cause various codes. So therefore, we have to keep an open mind on what's going on. I guess what I'm trying to say is when you pull codes out and you can run a test or you can see the codes themselves, please note, you got to make sure that all of these guys are all alive and well. And what I mean by that is the reductant control module, the turbocharger vane sensor, are they all working? Now there is a home test you can do, and when we looked at this initially, we're like, we know what's interesting, which I'll be honest with you, we haven't tried it yet because I haven't had a truck yet to do this. After I observed this diagram, is would it be interesting if I have an issue here with communication, that my best friend is going to be NOx sensor 1, which is located right behind the turbo on the catalyst, right behind the turbo on these L5Ps. Therefore, I'm going to see terminal 2, terminal 5, terminal 3, terminal 4. I'm going to see that I should be able to measure the resistance here. So here we could see one leg right here, and this leg should take me to that 100 ohm resistor. So 120 ohm, excuse me, 120 ohm resistor, and I should be able to see if I got good continuity between those, if not anything dropping the circuit down. And then on the opposite, I can go to 2 and 5, and again, I should measure again my 120 ohms. So that's something to consider, especially if we would have no communication or we got no turbo boost and a variety of other issues along with reductant control module. So these guys are they're pretty class A type of codes, meaning that they have to fail once. And in this case, it'll definitely cause drivability problems, an array of messages on the dash. So something to keep in mind as we were looking at this diagram once again is, again, you got two 120 ohm pretty much CAN networks right here that you can verify they're okay in the event that you got the circuit dropped and you got an array of different P codes and U codes set. So something to keep in mind there. So once again, if you have not learned the networks, haven't understood network communication, you got to get on that bandwagon and get to learn it. So that's why I wanted to cover that here. So hopefully it'll help you. So, okay. All right, moving on. So diagnosis, we've been talking about diagnosis in so many webinars, so many classes, and even I just did a class in Denver over the weekend at a summit meeting. And in this case, once again, I cannot continue talking about the L5P or anything else if you don't know or don't have a strategic approach. I know there's diagnostic trouble codes, and a lot of you tend to use that as your crutch, but it could also be your best friend. I understand that. But in this case, probably the most struggling thing that I've had lately on the phone has been, will you please read the DTC description? I'm going to talk about some of that here later on. But again, I understand diagnosis can vary depending on the issue, crank no start or a drivability issue. Yeah, I get it. But in this case, obviously, let's not forget about the basics and the visual inspection and your battery testing and the condition of the fuel and so on, right? So I'm not going to get into that too much because I already have covered diagnosis. In other words, the first steps. And if you haven't not yet sat down and say, okay, what am I always going to do first, second, third when I do a diagnosis, no matter what? If I'm dealing with an ABS problem, traction control problem, is batteries need to be inspected, connections need to be inspected. Yeah. So if I'm doing a drivability problem where it's fuel, turbo boost, engine miss, am I going to check batteries too? Yeah. And if I'm doing an after treatment system, is battery also? Transmission, same thing. So you'll notice that they cross correlate each other in terms of checking those basics, not to mention the official wiggle test of wiggling everything, because for those of you that have not worked a lot on L5P, let's roll back in time. You remember with the, what was it, the LLYs, LBCs, where we're having the pigtail connector problems on the injectors? Well, guess what? We're having the same problem number 4, injectors on the L5P. So therefore, we're having pigtail problems there. So that has not gone away. So again, wiggling and jiggling and inspecting connectors is still a basic thing you got to check. So, I saw this, and the thing is, this is pretty much the bulk of my phone calls is this: injector or no injector, to replace an injector, to not replace injector. That is the question with L5P. So, you got this guy that says, hey, I just bought a 2019 Silverado with an L5P. No sooner than 50 minutes of driving off the lot, my check engine light came on. Talk about crappy purchase there, man. Did he not test drive it? But anyways, I ran the codes and it popped up PO1CD, PO1D2, and a D4. These come back as fuel management codes. I look pretty hard, but haven't seen much as codes. But look at the truck mileage. It's 28,000 miles. So for those of you that don't know what these codes are, well, it's something that I've been discussing for a while that I need to cover here. So we see the cylinder 2 injection time in retarded, cylinder 4 injection time in advanced, and cylinder 5 injection time in advanced. So the novice guy is going to replace the injectors. But mind you, this truck has 28,000 miles. So let's get into this. We really got into this because it's not one thing that could be the problem. Okay, it's not one thing that could be the problem. So if we follow what the service manual, and there's a lot of good information we can infer with that, and I know that a lot of you have been struggling with this because the popular phone call has been this: well, I had these codes and they replaced the injectors. And in this case, the injector, upon replacement, did not fix it. Word to the wise, though, as you test this, no matter what mileage the truck has, please note, I assume you guys know that all the cylinders are working, because like the guy here even said, I don't know if I mentioned it, is that the engine runs great. Okay, the engine runs fine. There is no visible symptom problems. In other words, you start up the truck, starts up fine, but yet it is setting these codes. So we got to learn a little bit about these codes, because I've been asked questions about these 2 different codes, which is, well, actually there's more. There's timing, and there is quantity. So therefore there's timing and quantity codes. So therefore it says right there, the control module K20 learns the timing performance when the following conditions are met. So pay attention here. These codes are actually pretty much monitored under what conditions? decel condition. So it's under decel, which is an average of 20 seconds of decel. So if you want to run this code, you have to have a decel event. Now, right off here, the I-15, I got the perfect decel exit where I can actually decel for greater than 20 seconds. So that works out great for me. But I know that he's going to, again, run the test, because once again, the diagnostic trouble code is a test. So he's checking again the behavior of these injectors. Engine must be at operating temperature. So the computer will adjust the injection timing for each injector based on the changes in rotational speed of the crankshaft. So meaning that your crank sensor is your major input. Now the module, or the ECM, stores that injector timing module. Now, before you continue to understand how to run this test, yes, we just said that you must be under a decel condition, but even the conditions for running the code in the diagnostic trouble code chart states that obviously APP, you shouldn't have your foot on the pedal. Your ambient air temperature must be warmer than 19 degrees. Those of you, the guys that live in right now in cold weather, it's going to be a problem, isn't it? Because I know a lot of you are under 19. And then you got your barrel sensor, obviously 10 psi. That should not be a problem. Battery voltage greater than 11. And then no region status is not required. Engine speed should be between 1200 to 2100 during this decel event. Why am I saying this, by the way, for those of you like, well, in order for you to test, sometimes you're going to have the computer run the test again. Okay. Now, sidebar, you do understand, right, that if you haven't played with your GM portion of your scan tool, is that there is something called DTC info. So under DTC info, I can go to specific DTC and type in PO1CD, one at a time, PO1D2 and PO1D4, and I can see the status of that code. So if I do a deceleration event, it's going to say test run, yes or no. And you should say yes. So you know if it is failing, again, you can actually reset it. Because the reason why I tell you this is because don't forget, as much as these codes are here, computers can learn wrong. And you're like, what you talking about, Tony? Well, is there a reset for injection? In other words, adaptive values, injector adaptive values. So yeah, you can reset it. So if everything runs great, I shouldn't be saying this, but I'm going to tell you anyways. If everything runs great, okay, and you still got these codes set, then the best thing to do, based on what I've seen already, is let's reset the fuel injector adaptive values on the scan tool. Then I'm going to get it all warmed up, go drive it, and go on a decel event. And using specific DTC, I'm going to type in those codes, and I'm going to see if that decel event performed that test, and it'll tell me if it ran the test, yes or no. That's probably the best thing you got to do, because there have been numerous phone calls that I've got where they've replaced the injectors, they've done all this, and they never reset the injector adaptive parameters. I would have done that first. You follow me? So in this case, at that point, we're going to see if it was an erroneous learned value, or if it is a realistic that the timing is really needed to be retarded in advance. That will tell me. So what should the procedure be if you haven't caught on? You got these codes set. You've done your visuals, you've done everything, truck runs great, you've done a balance test, maybe everything looks hunky-dory. Okay, now what you're going to do is you're going to go ahead and obviously clear the codes. You're going to reset the adaptive values for fuel. And then at that point, you're going to get it warmed up, and you're going to find somewhere to do a long decel. And observing the specific DTC, you're going to go ahead and see if that test ran yes or no. Okay. Now, for those of you who know what the hell I'm talking about, in the scan tool, once again, under DTC menus, what you're going to have is something called, DTC info. And under DTC info, which is DTC information, you're going to see something called specific DTC. And that'll allow you to type in these codes one at a time and to see the status of those codes one at a time. And at that point, you're going to see test run, yes or no. Now, let's see what else. Requesting mill, yes or no. Has it failed since last failed? So you're going to see that. But what I'm concerned about is it actually, did it run the test, yes or no? So you should know by now, right now, that I just told you that this thing will not run by itself unless it sees a what again? A decel event at operating temperature. And here's the rest of that criteria. And make sure it's got fuel. Hello, fuel level's got to be greater than 10%, and it's got to be in third, fourth, fifth, or sixth gear. So there you go. Got it? Okay, so we move on. Again, if you got any questions, please ask. So therefore, the conditions, again, are going to be type B. Oh, I forgot about that. Sorry, good thing I wrote that down there. Ooh, forgot about that. What are you going to see right here? You see, I'm kind of spoiled by my Snap-on Zeus, because Snap-on Zeus gives me pending codes. Okay, so in this case, please note, I forgot about that. I screwed up, sorry, is that this is a type B code. Now, for those who don't know what a type B code is, type B codes means that it has to fail 2 consecutive times. So guess how many decel events I got to do? So in this case, I got to do 2. I forgot. Sorry, my fault. So in this case, that means what you have to do is you got to do 2 decel events. So I'm going to do 1 decel event. I'm going to come around my little route that I do. And then I'm going to pull over the side of the road, and I'm going to actually shut down the truck and let it all go to sleep, and then wake it up, start it up again, and start my next, again, test. At that point, I'm going to do decel event twice. So yeah, you got to do it twice. Okay. So hopefully you learned that. Once again, some codes are type A. That means if it fails once, boom, it sets. If a type B is going to be set code, that means it has to fail twice. So that would mean that these codes, once again, right here, the P01CD and P01CD2 and DD4, all the injection time and quantity codes are type B codes. It has to occur how many times? Twice. So that means you have to test it twice. Okay. So let's role play it one more time. Hopefully I didn't bore you here. Stay awake when you don't shut it. Don't turn off the computer. Listen to me. Come on. Okay. That means that, okay, I got these codes set. Everything runs great. It looks okay. I don't see no issues at this time except for these codes. Okay. Now at that point, I'm going to clear the codes. After clearing the codes, I'm going to reset the fuel adaptive values. I'm going to go do now at that point a long decel, make sure I meet the criteria, engine at operating temperature in the right gears. I'm going to do a decel event. I'm going to look at specific DTC to make sure that that code did run and if it failed or not. Okay. And if it failed, that means it's pending now. So I come around my route. Once again, I pull over to the side of the road, I turn it off, let it all go to sleep, maybe about I don't know, a minute, 2 minutes, fire it up again, take off, do the decel event here, confirm once again under specific DTC that that event did run, and that'll tell me if it passed or failed. So if it passes the 2 times, then therefore the whole problem was what? Adaptive values were learned wrong. Okay, once again, repeating, those adaptive values were learned wrong, and that fixed the problem. Okay, now what if it does not? What if it fails again and after resetting? Then therefore you know that you got to go further at this point. So if we use the actual troubleshooting chart from GM, you're going to see that they're asking you to verify that there's no other codes related to these components, from the crankshaft sensor, the engine coolant temperature sensor, all the way down to any fuel system issues that you could have. Hey, if the fuel filter's been replaced, type of thing. So therefore, don't even bother doing the test drive after you reset the adaptive values. Don't do none of that I just said if you have other codes set. You got to go after these guys first. Okay, so if you have an ECM malfunction, if fuel pump driver control exhaust, yeah, there's something else going on. But there's something that I should have put a note in here, because I've had this bite me in the butt too, is if you have done, the reset adaptive parameters and there's no other code set, General Motor Service information does state to make sure you have the up-to-date current software on the truck. So you may want to make sure it's got the latest flash file on it too. So there you go. Now, after that, if there are no other DTC set, then they're going to tell you that make sure there's nothing related to this. So this pretty much is what is related. So I guess what I'm trying to say is one of the first ones that I had this code with a few years back, it was a map sensor. And I'll do a little quick thing on the map sensor later. But in this case, it was a map sensor. And guess what accumulates? This truck did a lot of stop and go. So guess what was on the intake? Massive carbon formation. So in this case, definitely we had a map sensor. So therefore, map sensor, like we used to say in the old fuel injection days, we call it the load sensor. In other words, he tells you what the engine load is at because you're looking at boost levels and pressures that are in the intake. So therefore, that can really throw the balance off of the actual fueling of the cylinders. So it could affect 1, 2, or 3, because logic would tell me that if I had a map sensor skewed, shouldn't I have fuel injection quantity or timing or whatever codes set on all the cylinders? That's where we're a little confused, to be honest with you. And the answer is no. We only see a few cylinders do it. I've never seen one, and you got one who's had it all happen to all the cylinders, and let me know. But I've never had it so far. What the one I've seen and what I've had guys talk to me about, never seen one where all 8 set codes, all 8 cylinders set codes for timing and quantity. So in this case, EGR needs to be inspected, your intake air system, something as frivolous as your air filter can be the cause. But always remember something. An engine is an air pump. So the computer, that means that computer is looking for a certain learned speed of that crankshaft every time these cylinders are firing. So that means the intake flow and the exhaust flow must be within specification, whatever that is, according to the ECM. I guess what I'm trying to say is, if an air filter is restricted, is that going to affect the flow of air going in? And will that affect your combustion process? At that point, will it also affect your exhaust? And if the exhaust is restricted due to soot accumulation in the DPF, will that also cause backup pressures, or shall we say, back pressures up the intake of the engine itself? So there have been guys that I've told, the next step you may want to consider if the engine runs fine is, what is the differential pressure on the DPF? And maybe we may need to run a regeneration to clear the DPF. So there you go. Now, obviously, the next step that the service manual immediately tells you to do is they're going to tell you to run a compression test, because they want to make sure compression is good. Because if you have a drastic need to make fuel changes, the question begs, is compression test. But you know what I think it is? It's actually something we've been seeing in Duramax ever since its birth from LB7. You know what it is, especially in the high mileage L5Ps and L5Ds, is your valve lash adjustment. Have we seen, going back to the balancing rates, okay, those of you know balancing rates, have we not seen balancing rates affected by excessive valve lash on the valves / rocker arms? So please note as I go, this is funny because I bet you this is going to happen because nobody's adjusting, or not many are adjusting the valves when asked for by Duramax, which is what, every 70,000 miles. Severe do it every 50,000. So in this case, it isn't surprising I get a Duramax coming in, whatever year it is, and what I hear, tick, 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 and it's not the injectors, it's what? Excessive valve lash, and it requires valve adjustment, okay? So in this case, please keep in the back of your mind, can you also get an injector timing and quantity adjustment code due to excessive valve lash? And the answer is yes. So therefore, that's something to keep in mind, which will also affect your compression as well. So yeah, hello, yeah, that'll do it. So in this case, L5P, like we said, uses a, let me get rid of this for a second. It's blocking my view. Come on, get out of the way, get out of the way, get out of the way. Great, it's not getting out of the way. Okay, I got a box here, that's why I can't see you. All right, so the L5P uses a manifold absolute sensor inside the intake manifold. The MAP sensor is responsible for sending, obviously, the ECU vacuum positive air pressure readings, which are used to determine how much fuel should be sent to the engine for combustion. Like I said, the load sensing sensor. So at that point, like any sensor, the MAP sensor is prone to becoming clogged or gunked up, with which can affect readings being sent to the ECM or ECU. So on the L5P, the MAP sensor is known to become clogged with soot or grime and either fail or send, which we call skewed, by the way, incorrect readings to the engine's computer. So when the MAP sensor fails, incorrect vacuum and air pressure readings are sent to the computer, which then affects the amount of fuel that is being sent to the engine for combustion. Overall, a bad MAP sensor will cause poor performance and can lead to catastrophic engine damage. I guess that would be really bad. Haven't seen that yet, but I guess it can happen, if not in a timely manner. So there you go. So therefore, your job is to verify, again, the MAP sensor reading, see what it's reading. Now, you're probably saying to yourselves, well, shouldn't it have a code set? Maybe. But if it doesn't, it's because it's still within the range of pressure that it's supposed to be at. So therefore, it could be slightly or more, but it all depends. Okay. So therefore, it may or may not set a diagnostic trouble code. So keep that in mind. So what are the symptoms? If you have a gross MAP sensor issue, according to what we have read, and one that I saw was rough idling. I had a rough idle. So in this case, engine misfires. Obviously, the ratios for fuel to air are going to be off, but you're not going to know that. But you are going to see it in your balancing rates and your fuel trimming readings, your volume checks. And then lack of power and overall poor performance. So yeah, she's going to do that. So MAP sensor will be pretty obvious. But if you got these symptoms, I got to tell you something. I'm almost 99% sure you will have a MAP sensor along with other codes too as well. So be aware of that. So, and like we have said in diagnostics, in step 5 of your diagnostics, you should observe your PID list. What am I seeing for MAP sensor values? And a red flag is, where's your pressure supposed to be? Okay. Now we know with key on engine off, you should be reading atmospheric pressure. Once you fire it up, that's where the pressures start to change depending on the position of those vanes. So you could actually command the vanes open and close and observe the performance of the MAP sensor. But then again, one of the better things to do that might get you out of trouble is you may want to check again that MAP sensor physically. So, and therefore, if you understand a little bit of the history of the vehicle, is the vehicle doing a lot of stop and go driving? That's another thing that you're going to find too. So there you go. Okie dokie. All right. So after treatment issues, right? Another big dog. Will you please get up to speed on after treatment? Some of the phone calls I get are getting on my nerves a little bit because lack of understanding about after treatment. Come on, guys. We've been with after treatment now since 2007. Those of you that are day-to-day working technicians, come on, you should know after treatment pretty good by now. So we understand, again, that we can get soot accumulation, but always remember this. If you have not grasped this concept, is anytime on whatever engine you're working on, after treatment can only work properly if the exhaust integrity is good. In other words, there's no black smoke, there's no white smoke, there's no engine oil, there's no coolant, or there hasn't been any previous catastrophic engine failure, such as turbo, head gaskets, cylinder blowing up, I don't know. So in this case, it is important that you understand this, is that it only will work properly if exhaust. So I guess what I'm trying to say is, for quite a while, we've been telling you to uncork the exhaust. So the problem on the L5P is this. So we came up with this that seems to work, is we traditionally, on most trucks that have after treatment, we tell you to uncork the exhaust right at the downpipe. The problem is the L5P has the catalyst right butt next to the turbo. Well, how do you do that? Well, the problem is you can't. So, but right there on that catalyst, right behind the turbo, is knock sensor 1. Guess what? You can take it out, hang it to the side, leave it plugged in, make sure it doesn't get burnt in the wires. And what you're going to do is you're going to fire up the truck, and that'll show you what kind of smoke is coming. You're going to see a sample of the kind of smoke that's coming off. So therefore, I know it sounds Mickey Mouse-ish, but that's our only resort there, because that catalyst is right on that turbo. So your best bet is to take out knock sensor 1, leave it plugged up, hang it over to the side, leave it plugged in. We don't want to set more codes. And at that point, fire up the truck and see what kind of smoke is coming out. So if you've got a lot of pukey black, gray, white, whatever smoke, then you know that's a big problem too as well. So we need to see that. We've done it before in diesels, and these diesels are not any different now, guys. So hopefully you agree. Now, obviously, drivability issues require to keep in mind the effects on the after treatment. So therefore, leaky injectors, turbochargers, skewed sensors, like we just talked about MAP, will cause premature soot accumulation. But we need to add one more there, and that is how much blow-by or crankcase pressure is coming out of this puppy. Because if we have excessive crankcase pressure, that's becoming now the norm here, at least in my area and other shops I've talked to. Guys, take a look. Just simply fire up the engine and take that oil cap off, and let's see if this thing has been well maintained. Because I understand some of you might get a truck that has 60,000, some of you might get a truck that has 180,000, and now I'm seeing some trucks over 200,000 miles on them. So therefore, yeah, we don't know how well these trucks have maintained. So therefore, it begs the question is, where is, these, how well has been maintained, how much blow-by, because is blow-by the number one enemy of a diesel particulate filter? And the answer is yes. So therefore, and for those of you that are novice, your diagnosis does also confirm, hey, are all 8 cylinders working? You'd be surprised when we do that. So how are we doing so far? Are we staying awake there? Are we understanding what we're doing? So hopefully when you get done here, if you got a Duramax, for those of you who haven't done it, you'll take time to look at the scan tool. You'll take a look at some of your PID readings, and you'll look into under the DTC menu, go to DTC info, go to specific DTC, and you see what I'm talking about. So, all right. Everybody good? All right. Remember, like we said in part 1, to review part 1 here, we did talk about the FSA. So like it says right here on the slide, I don't like to read too much. I'm sorry, but I'm going to have to read this stuff though. So in the calibration controls community, this diagnostic, okay, this is calibration, in other words, fine tuning of the fuel set point. We call it the fuel set point adaptation. That's what GM calls it. So this is an algorithm that is used to estimate the actual injected fuel quantity. So this is estimated used on set points for items such as EGR, boost pressure, fuel rail pressure, and everything else that, again, that affects the combustion process and meet the load demands that you're requesting for that truck to move it and do its load and its job. So the goal of the fuel set adaptation is to account for injectors that drift during the lifetime of the vehicle, because that's going to happen. So the algorithm estimates the real injected fuel quantity by using input from the mass airflow, nitrogen oxide sensors, NOx sensors, and to determine the air-fuel ratio. So if airflow parameters are incorrect due to leaks, blockages, malfunction EGR, inaccurate mass airflow, NOx sensor inputs, or fuel injectors are just not performed as intended, therefore this skewed air-fuel ratio can negatively affect that fuel set point adaptation and lead to other codes such as your PO26C and PO26D, which are your other quantity and timing codes. So therefore, there you go. But like we've seen in the past, there has been numerous, hopefully you have updated the truck, but there are bulletins out there that I've asked you that if you do have these codes, and look at the array of codes, if you have not seen these bulletins in the past, there's that PO1DO and D4 that we said, is that they're going to ask you to make sure that you actually have the latest flash update. Now, there was also on a recall, which is, as you can see in the middle, number 4, which is the 17337-04 for the particulate matter sensor. So make sure you actually make sure it has the latest. If it's a 17, 18, I don't think this applies to the 19, but in this case, make sure that you actually, verify that it does have that recall done too as well. So, but you're supposed to have the reflash update file put in it too. So, okay. Now, with that said, as we were talking earlier, when you are looking, whether being timing, quantity, anything related to the injectors, and when you're looking at balancing rates, always remember that cylinder, as that engine's rotating, we're looking at the angular rate. So like I did this little pie thing here, what you are looking at is that on these V8 engines, we understand that the crankshaft turns twice for once of the camshaft itself. So that would mean that for one given revolution of that crankshaft, that means that 4 cylinders fire. So there's number 1 on here, over here. You can see my mouse, I hope. In this case, we see number 1. As a matter of fact, let me get my laser pointer up for you guys to see. So in this case, you're going to see number 1, then you're going to see number 2, number 3, number 4 in the firing order. And there's that crank sensor right there using, again, the indentations on the reluctor wheel to actually determine, again, the angular rate. I was trained with something called angular velocity. That's why I put it up here. And what it's doing is that it's looking again at when a cylinder fired, when that piston dropped, the question begs, did it contribute to, again, the speed of that crankshaft? So please note that it's looking on the balancing rates for starters, it's looking at it at idle. So in this case, when it's actually running under decel at a higher RPM, that means that RPM is slowly dropping, slowly dropping, slowly dropping. So therefore, okay, if it's looking at injector timing under decel, are the injectors coming on or off? But do we have compression events taking place? So think about that for a minute. So in this case, the question is that since we are looking at the angular when each cylinder fires and we're looking at the power it contributes, so therefore I put these things right here showing the angle rate, but the computer, what he's doing is looking at the time. So if an injector during its run at idle, he's going to look at the contribution of power. So therefore that would mean that at idle, as each cylinder fires, the power stroke per each cylinder speeds up momentarily the crankshaft, and the crank sensor is going to look at that time. How long did that event take for? In other words, boom, power stroke took place. It speeds up momentarily the crankshaft. How long did that take place? So did it overfuel? Did it underfuel? So his job is to continuously adjust that. Why am I putting this up here? Is that I just saw yesterday, as I was preparing for this, I just saw yesterday a bulletin talking about that you better look to see, if the truck has off-road tires. So in other words, the vibration from the tires, now they're saying, can actually cause misleading the actual timing and quantity codes. And I'm like, that could be, that talk about a sensitive thing. The thing is, it kind of surprised me GM would put that out, because for the longest time, even when I taught gasoline fuel injection back in the day, there was rough road logic. They used to call it rough road logic. So in this case, that would mean if you go in very rough terrain, is that going to also affect and cause false code set? So there you go. Okay, so for those of you that didn't get that previous graph, I made this guy. So it's kind of a pie chart, kind of shows you can cylinders, depending if there's a compression issue, a valve lash issue, like I mentioned already, injector nozzle clogged up, so restricted or leaky injectors, can that cause one cylinder, again, provide more power than the others? And that's what you're looking at there. So hopefully that makes sense. All based on crankshaft position. Yeah, crankshaft angular velocity as well. So like I mentioned in the last class too, again, there are codes for this, in other words, for timing, and there could also be airflow issues. So therefore, let's not forget that the air filter, once again, repeating, can be an issue as well, along with carbon formation. So definitely a lot of carbon formation. So now as we're seeing these trucks, depending how they're driven, okay, depending how they're driven, that means it is okay to sell a customer if you can stick a camera down the intake. That would be interesting, because you can actually sell intake. We're selling them in gasoline, guys. So why not do it on diesels? Lord knows I got all the stuff from BG on that, where I can actually run an intake clean. They sell the chemicals for a diesel where you can actually do an intake clean. So therefore, what it is, it's again a plate that goes over the intake throttle. You remove the boot, put it in there, and it actually creates a vacuum with that little orifice within it, and it actually shoots a solvent to actually dissolve a lot of that carbon formation in the intake. So it doesn't necessarily mean that we have to take the whole intake off and clean it, but maybe we can do premature servicing of that. So something to keep in mind. So therefore, yeah, that's what we're looking at. So now I've been a big BG 245 user, not that they're paying me any money, but BG 245 is a very aggressive cleaner. and there are other companies selling their version of a cleaner. The reason why I mentioned this guy is because injectors can get prematurely clogged. I can't tell you how many times we've seen 245 perform. I'm not telling you got to use it, use whatever cleaner it is, but it brings a point that you may want to run a cleaner additive. There are other companies that tell me, I've yet to try them. I got to try them. I haven't had time to. But in this case, you need a cleaner to clean those injectors. And what I mean by that, again, we have often said over and over and over again that what is the number one enemy of common rail has always been what? Contamination. So we see nozzles where a certain spray pattern or just squirting directly, we can have issues with that. So a good cleaner can also alleviate, because that can also be your problem in causing these various different codes to set. Okay, so keep that in mind. Now, obviously, your mass airflow sensor is no different. So therefore, we have to observe the mass airflow sensor, know and verify the grams per second. Again, your generic range should be between 5 to 40 grams. It is going to vary depending on engine load and what altitude you're at. But remember, mass airflow needs to be checked as well, visually too as well. And going back once again, third time is the air filter too as well. And guys, are we going to be in trouble if we're running some kind of fresh air intake? You know, the big problem here. So therefore, definitely want to pay attention to that too. Is that air clean, and is that mass airflow damaged or sandblasted? Here in lovely Las Vegas, where I'm in the desert, we have seen sandblasted because our number one problem here is dust in the air. You know, so we're getting high winds here for the last 2 days, 3 days. And in this case, it isn't surprising that we see a lot of dust on those intake tubes because of poor filtration. So there you go. Now, please note that if you got a PO1DO, it can go as bad as going to reduced power mode. So in this case, please note that it can go to, if you do have a PO1DO and that's the only code you got, it can go into reduced power because it says I can't control the fueling on that. So be aware of that. Now, I've dealt with other shops about this, you know, about the fuel pressure regulator connector. Please note, there have been a bulletin on this, a lot of bulletins about this, especially on the regulator and the fuel rail pressure sensor. Now, the fuel rail pressure sensor is a 2-in-1 sensor. It's got 2 sensors in one on the L5P. So therefore, corrosion, I mean, these connectors are pretty much junk. So therefore, it is a wise idea in your initial visual diagnosis, especially if you got a fueling code or drivability code, you might as well take a minute to check these connectors from the fuel pressure connector to the fuel rail pressure sensor connector as well. So therefore, definitely want to check to see how they look. So here you can see an example. And in this case, you definitely want to check them because this has been a never-ending problem right now at this point that I've seen so far on the earlier models. Can't say that I've seen anything like this on the 2020 models. If you have, let me know. That'd be nice to know. But in this case, 17, 18, maybe 19 models. There is an updated kit that they sell you, and they're telling you to actually put a new pigtail, but also put mega dielectric gel. So now that I checked an L5P, I pulled it off, and if I see a good amount of dielectric, that means somebody's already done the update already. So keep that in mind. So now, we also talked about the lip pump issues. I'm going to breeze through this because I already mentioned it already. Again, look at part 1. But always remember that we do have a 3-phase pump. We talked about the initial lip pump issues going on with the L5P. And the struggle has been, okay, is that we got a pulse width modulated 3-phase pump controlled by a fuel pump driver module. But initially, you do have the ability with the scan tool to look at your pressures. So therefore, I can look at lip pump pressures, which again, the spec is between 54 to 65 PSI. Now, the sensor and the whole indirect injector are all down next to, right over and over the, right just in front of the axle itself on the rear end. But it's all down there. It's not up in the engine compartment. So for you guys that are new to this, please note that is way downstream. So fuel filter and indirect injector and the fuel pump driver module are all on the back end of the truck. That's where you're going to find them. So therefore, that's where your diagnosis is going to be under the vehicle to see what's going on. But for now, with the scan tool, you should again see 54 to 65. So be aware though, we already nailed one. And in this case, I saw the readings go erratic, and my mindset was, let's just keep an eye on the pressure. And it didn't occur to me, you know what, Tony, you haven't wiggled that connector off that. So why don't I go down there? So there you see me getting underneath the truck with the truck running and with the scan tool in my hand and start wiggling the connectors. And guess what? Had a bad connection there to the sensor itself. So don't forget about the wiggle test there, especially if you got erratic behavior of the fuel pressure sensor. Maybe it's not nothing to do with the pressure or the fuel. It's just the electrical connector going to the sensor. So do wiggle. You'll notice there on the diagram number 6, that is your indirect injector. So in this case, unfortunately, the indirect injector is located right in front of the oxidation catalyst, the second oxidation catalyst downstream of the exhaust. So it's after the SCR. So those of you that haven't noticed that, yes, that's unfortunate because when you run a regeneration, you are just cooking the diesel oxidation catalyst with the DPF. So therefore, there is a regen, but it's not heating the SCR. So if heating of the SCR needs to take place, that means you got to drive that vehicle hard or run some serious RPM on it to get it nice and hot, because that can also cause accumulation of crystallization of the DEF fluid itself that can happen. So, but note, I don't want to get into this area yet, but note please that again, you can see the speeds of that fuel pump module, and I did mention this. I showed you this where you can view the circuits of that 3-phase. And in this case, you're also going to see the desired and actual fuel rail pressures along with your low speed pump commands too, not to mention RPM. So you can see all that right there. So pretty nice. Got to play with the PID list. Maybe we'll do another L5P where I'll just talk about only PID list. Maybe I'll do that for you so you guys can get more acclimated with it. But hopefully you can spend time on a good run in L5P. But the one thing that I did cover on part 1 that I'll just say one more time is that you may want to look at pin 18, okay? As you look somewhere around the spare tire area, you're going to see the, the fuel pump driver module, okay? Fuel pump driver control module, excuse me. And in this case, that is the K111, and there is a connector. So you're going to see the P12A6 as mentioned from GM. They're going to mention that you do want to disconnect the connector and you want to go after pin 18. The reason why pin 18 is important because that's the guy that gets the signal directly from the ECM to turn on the pump. So the best thing you can do is do the key on test, turn the key on, and you're going to actually probe pin 18, and you're going to see if it is getting a signal for at least 30 seconds, right? So definitely want to pay attention to that. So unfortunately, like we said, fortunately, I said, the driver control module, if need to be replaced, it is plug and play, does not need programming. But here's what I wanted to dedicate a little bit of quick time here. Quick time, that doesn't make sense. But anyways, timing here is that we mentioned already on part 1 about the power and grounds here taking place here. And in this case, please note, you're going to see a fuel pump here, but that is your transfer pump right there. Your main lift pump is this guy right here, which is again a 3-phase pump. Now, if you would like to see more about 3-phase pumps, it actually is pulse width modulating. And in this case, it will require you, the best tool to have is, you could use a meter, you could use a meter, but a scope could be your best friend to see what's going on. We've seen it, gasoline has been using 3-phase pumps for quite a while now, so therefore we can carry over their information, what they're saying. Now, I just covered electrical, and I've been doing a lot of electrical because we're going to launch some electrical training here that's going to be different. But one of the struggles that I have with technicians understanding is voltage drop testing. And the reason why it's more important more than ever is that this guy, meaning the fuel pump driver module, you need to make sure she's got good battery power and ground. So there's your ignition feed at pin 17. There you could see your battery power on pin 7. And there's that signal wire we just mentioned on pin 18. So therefore, this is the signal wire. I could see, and I haven't seen it yet, don't get me wrong, but I could see this something we got to understand is that a lot of guys are going to disconnect the connector and they're going to go ahead and measure those voltages right there. And that's what we call open circuit testing. That's nice, but that does not have any current flow through it. So what needs to be done, especially when we're going to get erratic behavior of the lift pump, is knowing where this thing is at and knowing where the connector is at, you may want to start prepping yourself for understanding voltage drop testing. What I mean by that is there's my ground at cavity 22. What I'm going to be doing in the future when I'm diagnosing erratic behavior of lift pumps, and maybe the shop is, you got to understand, I get trucks from other shops. is that they're going to be saying, well, we already replaced the fuel pump driver module, we replaced the lip pump, we still got erratic behavior, and we did check power. And the question I will ask them is, how did you check power? Well, they did it with the connector disconnected. Well, maybe we got a huge voltage drop going on. So therefore, what I'm going to be doing is going between cavity 7 and cavity 22. Turn the key on. Let's measure that voltage for those 30 seconds. And then I'm going to go from cavity 17 to cavity 22. Because what I'm doing is, do I have good ignition power and good battery power right here? So that's where, if I follow these up, that comes from a relay and also a fuse. So when we're talking about relays, what do you think is going to happen with relays? We're going to have contact issues. So we could have a high resistance fault in the relay, but then again, we could have, again, something going on in the wiring, because again, this fuse block is underneath the engine compartment. That means these wires travel all the way back to where the spare tire is at. So I can see issues going on with this wiring, especially if the truck's been in a lot of water, mud, terrain, whatever. Yeah, you do want to do voltage drop testing here, again, from 7 to 22 and 17 to 22. Very important to do. Everybody follow what I'm saying? Not to mention with time, and I'm not even going to get into this right now, but here you can see pretty much your data communication going on between the network itself and the instrument panel cluster. So therefore, that's another set array of wires that are communication that cause U codes and erroneous behavior, especially of the instrument panel cluster and the fuel pump driver control module. Oh, it just gets prettier, don't it? So therefore, please keep that in mind. And that's one of the reasons why I tell guys, again, can we please learn electrical so we understand how to do proper voltage drop testing here? Now, I know what a lot of you are thinking, and it is a wise idea, is that, well, if I suspect I got a voltage drop problem, probably the easiest thing to do is to go after this main relay, and you could. You could. Let's go after this relay. Let's see if my issue is resolved. If it's not resolved, then therefore, yeah, we're going to go down. We're going to have to get to this fuel pump driver module, and we're going to have to do, again, a voltage drop test, which means back probing here, and it ain't going to be fun, but we got to do it. So therefore, and always remember something. I know if I was a corporate instructor, I'd be telling you not to back probe, but the reality is we should be back probing, and there's a wrong way and a right way to back probe where you don't hurt the insulation. So, and there's so many kits sold out there for back probing, you ought to be doing it. So, okay. Now, in the service info, there is a little bit of depth testing which require phase testing independently. Again, what is it? We're going to check, let's see, we're going to do 8 to 9, and then to 24. So therefore, you're going to see 8, 9, and 24 right there off the fuel pump driver control module, and it will be an average around 6 volts. But in this case, you should do an amp clamp test too as well. But it's better to do it with a scope there. So therefore, you can definitely put a scope amp clamp on it and look at voltage too, because if you have a multi-channel scope, you can put the amp clamp on 8 and put the your volt probe in there too as well, and you can see what's going on with each one. But average is somewhere around 8. So in the future, when I get another L5P and I got a fuel pump problem, we're going to get our scope out and we're going to start taking some recording readings. So therefore, we'll talk about it in more advanced L5P courses, but you could do that to see electrically what's going on. So, but again, always remember something though. This is based under the understanding there's nothing wrong between 1 and 8, 2 and 9, 3 and 24, and 4 and 23, which I've seen in the past with other gasoline applications that I've only worked on a few. So there you go. So therefore, pay attention to that. So now, obviously, you do have a lot of bidirectional control. So remember, you can raise and lower pressures and play around with it. That gives you better control to understanding what's going on and look at what happens to your pressure. So you guys are probably already aware of that. And obviously, it doesn't hurt to do a test drive and do a record feature where you can see if the desired and actual rail pressures are all there, especially under an engine load, under a very heavy load. So put your foot on it a little bit to see what's going on. So. And General Motors even says that, again, your desired and actual rail pressure should not be greater than 290 PSI. So be aware of that. So, and obviously there is a lot of return tests that you can do. It's very minimal, But in this case, you can do a cranking test. You can follow the service info and you can see what's going on with the regulator. But I like this one because, again, we're checking to see that there is less than 10 millimeters on that PCV to check to see if you got excess leakage. Because one of the problems you're going to have, with contamination is the fact, and what I mean by contamination, especially with this Denso common rail that they're using here, is not so much metal, guys. It's so much just dirt and grime because this truck has had poor maintenance, poor fuel filtration. And in this case, we're looking at that, that I call it the PCV, but they call it the fuel pressure regulator too. And in this case, we like to remove it and inspect it and check for contamination. That's great. I've been doing this on other applications too as well. But there is a spec from General Motors saying that you can actually crank her over and see what it is for 15 seconds, should be less than 10 milliliters coming out of there. So in this case, that would mean that we're disconnecting this hose right there and doing that test. Okay, so yeah, I do realize that we are dealing with a common rail and is susceptible to all the normal common rail issues. So haven't seen one with metal contamination. So no metal. Again, one guy just told me I just saw minimal contamination, but again, there can be excessive contamination or excessive return going on there, which could be indicative of injection pump issue. So there you go. So now remember, you do have codes. I mentioned codes earlier. We do have codes related to the fuel pump driver module. There's description, operation. So like I said at the beginning of this presentation, it is imperative to read diagnostic trouble code info, see what's going on, understand what their ranges are and how it all works. So therefore, please note that, so it talks about that in the codes. And it even tells you in the test to test for continuity. Here you can see a continuity test you can do in that pump between 8 and 9, 8 and 24. So sorry, I forgot to move this slide up. I should have put it on before that, but there you go. There is continuity tests you can do too as well. So all right. Now, we talked about this at the end of part 1, where we had the vehicle actually setting multiple codes. In this case, P0087, P129F, P228B. And in this case, the truck was stalling, but the truck only has got 1,404 miles. Now, the codes are fuel rail pressure, low, fuel pump driver control module, signal incorrect, and fuel pressure regulator to control. So in this case, the truck's going into a derate, lack of power, then it comes back and all works fine. Then it goes back in derate, and these are the codes that it sets. So if you understand common rail, we understand that in common rail, there is a low pressure and high pressure and a return. So you cannot properly diagnose the high pressure unless you first confirm your low pressure, which is your lift pump. So that's a whole song and dance, but look at where you got there. I got that P129F, which is fuel pump driver control module, fuel pump signal incorrect. Now, I'll be honest with you, this has not been as easy as you think it is. You're like, well, I could read the pressures of the lift pump right on. I could see the speed of the pump. But at the same time, we've been very flustered with understanding, is the pump problem the pump, or is the problem the fuel pump driver controls? Now, I ran into a few dealer techs this past weekend, and we just happened to be talking about the L5P, and they're like, Tony, our policy is we replace both. We do the pump, and we also do the fuel pump driver control module. And I go, sometimes that fixes it, and sometimes that does not fix it, right? Remember the connectors too as well. We got to check the integrity. So question A, can a fuel rail pressure connector cause this? Yes, there's even bulletins on that. Can also poor fuel cause this? In other words, is it contaminated with that fuel? Is there gasoline in there? Can that also cause it? Yes. So don't forget about the quality of the fuel. So don't forget about that. I can kick your butt on that. And then what do we got? We got a fuel pressure regulator to control, so therefore forced shutdown. So the forced shutdown is meaning I'm going into derate, and that's what the customer said was happening. So we need to focus on what? The fuel pump driver control module. So I'm going to check to see if there's any problems with the phase circuits. That'll be displayed on the pit list. And then we're going to do a volume test, because I finally got ticked off working with some shops. I said, you know what? We're going to do a pressure test, and we're going to do a volume test to see what's really going on here. See if it is dropping and not dropping, because we could have a problem on the high pressure side. So therefore, that's where we do that return test as well. So don't forget about the return side as well, because that can also be causing issues. So, but I'll be honest, many times, many people I even looked on some other of the service information like Identifix and see what fixed a lot of these problems. Yeah, a lot of guys have replaced the connector off of the fuel rail pressure sensor, and that was the problem causing this to occur. So now this truck has only 1,400 miles, so yeah, I'd probably be going after that connector. But again, do I have contaminated fuel as well? So let's not forget those basics too as well. So, all right. Now, always remember you do have an array of other. Here you could see on my scan tool, if I can get this thing to, oops, I know what's wrong here. You do have a lot of information available here. So therefore, as I can play this, you're going to see that there's your engine oil life reset. But then again, there is your cylinder power balance, and you could kill one cylinder at a time. So you can still do all that. Not to mention, you got your reductant system warning test, your output controls. But this is where I want to get after here is I want you to notice a few things. Whoa, let me backtrack here. Let me pause it here. I don't know if you caught it under output controls here. This is what I wanted to show you here. You're going to see all the resets under output controls. And under output controls, let me pause. Oops, come on, pause. Thank you. Stop right there. You got your, again, your barrel sensor reset, your catalyst reset. In other words, you're going to see quite a few resets here. Exhaust gas temperature sensor reset, fuel injection quantity data reset, one of your fuel resets right there that I was talking about. So in this case, please get acclimated with all the resets that you can do because everything has got a learning or adaptive strategy. So it could be pertaining to your system. So the one that stood out for me that I didn't realize there was that barrel sensor reset. So if I were to be doing a new set of injectors or did some major repair, yeah, or I cleaned carbon out of the intake or cleaned out an intake, maybe it's a good idea to do a barrel reset to see what now it's going to read because that can actually set. Because one of the silent pits, I call it the silent pit now, is that barrel sensor because I have seen where I go up and I tell Siri, hey, Siri on my phone, I tell it, hey, what is the atmospheric pressure where I'm at? And then it tells me the atmospheric pressure, and then I verify it with the scan tool, and it might be half a pound to a pound off, and that's enough to cause issues. So don't underestimate the barrel sensor there. So there is a reset now on those L5Ps from. And here you can see the rest of those resets you can do here on an L5P. So the list is long and for you to confirm to see what's going on. See that? So obviously you got your operation of reductant pump. There's your NOx sensor resets as well. So that's always been known. Okay. So again, everything for you to get acclimated with. Obviously, I can't cover each one here in the presentation, but I definitely can see what's going on in terms of, the resetting of a lot of different components. So adaptive values, guys. So here you can see on the L5P after treatment, there's a reductant control module. There is our whole, again, reductant pump. And in this case, along with the sensor, the quality sensor, yeah, we do now have a reductant depth fluid quality sensor. See what's going on. It's 32.5% solution of urea mixed with water. So we see the DPF pressure sensor, differential pressure sensor. So let me start over here. Not confuse you. Hello. Here we can see the start of the after treatment system. There we can see an exhaust gas temperature sensor number 9, our first NOx sensor number 15, and our second NOx sensor number 15 right there. Don't confuse that with number 12. Number 12 is your particulate matter sensor. So in this case, 18 is that oxidation catalyst we have right behind the turbo. Then we have your DEF or reductant or doser that's injecting the DEF fluid to this SCR catalyst or NOx brick, number 16. And then we got number 10, which is our hydrocarbon injector injecting fuel into another oxidation catalyst, which chemically reacts and creates a hellacious amount of heat and burns off the soot in the DPF. And then again, we got our particulate matter sensor detecting remaining soot that might be accumulated in the exhaust. Now, we've talked about after treatment. That's been another presentation. The other thing I want to show you right here has been that the hydrocarbon injector is at the tail end of this exhaust. So therefore, once again, when you run a regeneration, okay, when you run a regeneration, it is only going to, again, heat the DPF, and that's it. It is not heating the initial catalyst or heating the SCR catalyst itself. So if this truck does a lot of stop and go driving, a lot of idle time, yeah, you're going to have to really nail it down, get it, put some RPM in it and get it to wake up. So you could run a regen because it still elevates the RPM, but it's best to drive it hard as possible to try to, again, get some of that excess ammonia and that excess, defluid that's coming out of there. So there you go. All right. So there's a picture of that catalyst. For those of you who have not seen an L5P, that's the one right after the turbo. So this is the back side of it. So it is not going to be fun. Any of you that have done these already, you're going to find out that the turbo would probably be best to be removed because everything's so tight. But here's your mini downpipe going down to where it meets the rest of the exhaust system. So again, you could uncork, but the problem is you got this guy in place. So therefore you would have to take, this is the bungle right here for the NOx sensor. So like I said, you can take out the NOx sensor and that'll show you what's going on right there. So, all right, recapping of what I said. Now, the NOx sensors. This is an important slide. Boy, is this an important slide. I don't care what diesel you're using, it did cover this. And I actually got it directly from the service info because when I did it as an exercise in my classes, I was like, whoa, let's read this. And this is very important. I can't tell you how important this is. And you'll see why here in a second. First of all, it's talking about the NOx sensor. That's the title of it, okay? It says clearly here that the ECM energizes the reductant injector to dispense a precise amount of reductant upstream of the SCR in response changes to exhaust NOx levels. Now, when a system is injecting the DEF fluid, what is telling the computer to tell it how much? In other words, how does it determine how much DEF fluid to inject? Squirt, 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 squirt DEF fluid. What determines how much DEF fluid needs to be injected? Because let me tell you, here's the next complaint that we've been getting a lot of. Hey, Tony, the truck's coming in, and dude, I'm going through DEF fluid like there's no tomorrow. I mean, I'm supposed to get better economy of my DEF fluid. And what I mean by that is this guy's going through, a full tank of DEF fluid within 300 miles, right? You're like, well, the truck's running loaded. No, he's not running loaded. There's excessive consumption of DEF fluid, and it may or may not have NOx efficiency codes. So therefore, we see that complaint now going on is I'm getting too much consumption of the DEF fluid. So let's keep reading. So feedback from NOx sensors 1 and 2 allow the ECM to accurately control the amount of reductant supplied to the SCR. That is false. It is inaccurate. Okay, but here's the answer though. They gave you kind of an erroneous statement, but they also gave you an answer here. If more reductant, now y'all understand reductant is the DEF fluid, right? So if more reductant is supplied to the SCR that is needed for a given NOx level, the excess reductant results in what is called ammonia slip. Okay, so therefore that is where significant levels of ammonia exit the SCR catalyst. Okay, so therefore there could be excessive ammonia slip. So let's backtrack. That's why I said you guys should know this by now, because you should know by now. All right, I'll say it, that when we inject DEF fluid, it readily converts into ammonia. However, there could be excess reductant or DEF fluid, which results in excess ammonia, aka known as ammonia slip. That's what ammonia slip is. So therefore, this is where significant levels of ammonia exit the SCR. So there's going to be excess ammonia. So why did this happen? This is the answer here. Again, this is very precious for you to understand, and hopefully you can see the importance of this damn slide. Since the NOx sensors are unable to differentiate between NOx and ammonia, ammonia slip will cause the NOx sensor to detect higher NOx levels than actually exist. Again, let's read this again. Since the NOx sensors are unable to differentiate between NOx and ammonia, the ammonia slip will cause the NOx sensor 2 to detect higher level of NOx levels that actually exist. So if he thinks that NOx sensor 2 says, hey, I got higher levels of NOx, what's the computer going to do? He's going to inject even more what? DEF fluid. And that's where you have excess. So therefore, if there is excessive ammonia, that means that we need to get that ammonia out of it. So how do you do it? Excuse my language. You got to drive the shit out of it. Literally, you got to drive the holy heck out of it. Normally, I would say run a regeneration, but since that region occurs after the SCR catalyst, that means we got to go get it nice and hot. We got to get it toasty to get some of the ammonia. That's why some of you that have done regenerations in the past on some trucks, you may have noticed that the exhaust smells like Windex or window cleaner, which is the ammonia you're smelling. That means that there probably has been excess DEF fluid being injected. All right. So let's backtrack to the main. Let me go back to my main chart here. So for those of you who don't understand. Okay, here's your DEF fluid reductant doser right there, okay? So as a matter of fact, let me pick some colors since I got a little bit of fun to do. Let's have some fun. Let's pick blue. I think, was that blue? I don't know what I picked. But anyways, there you can see, oops, come on. You are not being nice to me. One more time. Actually, let me do it this way. Okay. All right, here's your reductant injector right there. He injects the DEF fluid right here, okay? So therefore, we got DEF fluid coming in here, so it readily converts to ammonia. So here is my NOx sensor right behind the whole enchilada right here. So there you could see the NOx sensor. So he's going to detect what are those NOx levels. So in this case, he wants to know what the amount of NOx is there. So there's my NOx, okay? But if there is excess ammonia here because this DEF injector is injecting too much, the book said right now that we just read that he cannot differentiate between NOx and ammonia. So therefore, he's going to think that it's got excess NOx. So that means this computer is going to command more what? He's going to command more DEF fluid to be injected. So now you're consuming even more, and you're creating probably a little bit too much ammonia. And again, this will cause a problem. And eventually, you should get an inadequate or NOx efficiency code set. So therefore, you should see a NOx efficiency code set of some kind, or you can have various other NOx-related codes too as well. So what is the cause of this? The cause of this is this truck does a lot of idle time, a lot of slow time, meaning it's not loaded very much, doesn't ever get warmed up. Is it possible that we could be loading up with ammonia? Yeah. That's why the sidebar on this, the Ram Dodge has a ammonia slip catalyst. Okay, General Motors doesn't use one. So in this case, they do have a catalyst to absorb that excess ammonia on a Ram Cummins. At the tail end of it, there is an ammonia slip catalyst and also a ammonia sensor. But General Motors doesn't use this on the L5P. Now, I haven't checked 2023 models. Okay, I'll be honest with you. I haven't looked at a brand new truck. But in this case, I know that the 21, 22 models do not have it. So there you go. That makes sense? Do you understand the importance of that? Because this is going to be a problem for us, and it is a problem for us, especially where the complaint is excessive use of DEF fluid. It's consuming too much DEF fluid. So therefore, that could be the issue. And the answer in reality, if everything's working properly, it could be the fact that there's just excess ammonia because there hasn't been enough heat. So therefore, we got to burn that ammonia, get that ammonia out of there. So therefore, it could do its job to convert the NOx to friendly gases from nitrogen to hydrogen, nitrogen to water and to carbon dioxide. So makes sense? Hopefully it does. Okay. Hopefully it is helping you guys. So I hope you do understand as I'm closing up here that the NOx sensor is also known as again, an oxygen sensor. So please note that it does have its normal operating. It is electrically heated, so therefore it is doing its job. But again, it can get contaminated as well. So always remember, though, there is a NOx catalyst reduction loading reset. You can do that too as well. So please be aware, especially if it's been replaced, don't forget about resetting that too as well. So, and obviously this is just telling you that it's how it actually uses the strategy for NOx, but always remember that this is under the assumption that there is no intake leaks, because intake leaks can cause it. So we can have issues with NOx. So the classic one I've been talking about for quite a while was from an LML, but it could carry over to L5P, where I had NOx sensor 1, NOx sensor performance, and that was the only code that I had, and it was running great. And turns out it was a fueling problem. So I had to reset the fueling. But had I had a boost leak, an intake leak, an EGR base gasket leak, an intake leak, that could have been the problem. So I cannot stress enough now how, when you're dealing with these issues, that you need to have a smoke machine. You got to get that out of the way. And I got to tell you over and over again, I've said this in other previous webinars and training, has been that these smoke machines have been awesome. They now have dropped in price, but it's pretty much a must-have tool. You may want to do your research because there are now cheaper ones out there. They dropped in price. And what you want to do is smoke up that in will take as much as 28 psi, where you can actually check that as well. So definitely something to check, So smoke them up. That's all I'm saying. Smoke them up. Get acclimated with your PID list. Play with your PID list. See everything that's there. And the one that stood out, like I said already, if not, I'll say it again, is that you may have noticed that we do have, again, as a matter of fact, you're going to look over here. You're going to see that we have OK messages right here. And these are telling you the status of circuits for the fuel pressure regulators. So this is regular 1, regular 2. So he will tell you if there's OK or not OK issue right there. So therefore, if you do have a circuitry issue, a connection issue, maybe a pigtail issue on these components, you're going to see that now actively the onboard computer is giving you a status of those circuits. So you got to start playing around with those lists and go through them thoroughly. So there you go. Hey, let's not forget that as we talk about diagnosis. So there you go. Always remember, as a last thing, and again, this is all part of after treatment, that there is a specification for how much that reductant injector, or again, your reducer should be injecting. So therefore, follow the procedures from then as they tell you to do so. Well, what do you know? I'm about 8 minutes early, so I guess we're ready for some Q&A. If there's any Q&A, please ask any questions. Hopefully you learned a little bit. I did cover a lot of in-depth stuff, so I try to pace it and make sure hopefully you're getting it. But this is a need-to-know stuff that you got to know why these trucks do, because replacing just components such as injectors, and you still got the same code, or replacing knock sensor, you still got the same problem. Or maybe you cleaned out the whole DPF or whatever, you still got the same problem. You got to see the big picture. So how did we do, Mr. David?
I think you did very well, Tony.
Thank you,
To say you
sir.
covered a lot of very, very good information. I'm sitting here and I don't necessarily work on vehicles every day, but it's super interesting. And I think to myself, wow, a technician's got a lot to learn these days. It's just
Yes,
becoming more and more complicated, but you do a great job of covering all of this information and we really appreciate it. As Tony said earlier on, these presentations that we did last year, I think we did 4 of them last year. This particular one that we just covered today should be up on our webpage in a couple of days' time. And as Tony said, if you go to the
YouTube.
what do we call it? YouTube channel, and you put Lucas Diesel Systems in there, you'll find all of these presentations. So therefore, then you can refresh or share them with your fellow technicians. I do have a few questions. One of them says, what is normal versus not normal DEF consumption?
The manufacturers have said somewhere around 1 gallon for every 300 miles. But unfortunately, that's not entirely accurate because based on if the engine's loaded and temperatures. So in this case, the customer itself is going to be the judge of that. You're going to have to take his word because of the fact, unless you bought the truck with a problem, but is because, you're going to see that, like, for example, I got one truck and he goes through 2.5 gallons every 3,000 to 4,000 miles. So therefore, that's the ballpark range that I see. So if we see within 1,000 miles, 2 gallons of consumption, yeah, that's excessive, So therefore, to say that there's an accurate, no, but different manufacturers are telling you their specification. And the average one that I see is about 1 gallon every 300 miles at the most loaded. But in this case, I'm like, that's kind of high for some engines, but low for some other engines. So it all depends. But average, yeah, I would say 2.5 gallons, which is the average bottle that you buy, like the Blue Def stuff. That should last you at least 3,000 to 4,000 miles. But again, we see more consumption on that. So,
okay, thank you, appreciate that. The other one is regarding scan tools. There's so many scan tools out there on the marketplace, such as your Snap-on, your OTC, all of the OEM scan tools, as well as another one called Kojali by Haltest. You ever thought of doing a seminar on scan tools? not necessarily to pick out which is the best one, but just to give some of the pros and cons. You know, it's
Well,
just
I got two of them because I've kind of finally downgraded my number of scan tools I got. But yeah, I can do Snap-on and my other one I got. But yeah, and we're working with, and that reminds me, David. Yeah, we're see if we can do the Cojal scan tool too as well. Do a comparison, talk
right.
about it too as well. Yeah, it's something that we definitely can look into. So.
Okay, sounds
But
good.
please understand, it all comes down to preference. You know, a lot of technicians are, I watch technicians act, especially when I do my classes, my live classes, and they bring their scantals or I go to their shops. And in this case, we are, you can see how they're used to their methodology of using their scan tools. So I guess it all is preference what you like to see. So
Okay. Another question says, do you see similar injector timing slant quantity code issues with LML?
no, haven't seen, from my experience, no,
Okay.
no, I have not seen them. So. No, sir. The answer is no. I have not seen one LML, not one. Usually we look at the balancing rates heavily on the LML. So
Okay. The
it
other
seems
one
to be, and
next.
it seems to be, if you don't mind me saying, it seems to be an L5P, L5D thing that Jim is focused on. Yeah.
Okay.
At
All
least
right.
from my perspective. Okay. So
Sure. Another question or statement. Have you thought of doing an after treatment seminar?
we did one.
We did one. Okay.
We did one. What? It's already up on the Lucas site. So we have done one. So
It is. Okay. All
yeah.
right.
So you can go to Lucas YouTube. But I also did a four-parter on my channel too, Diesel Talk with Tony Salas too. So if you want even more another version of it, you're welcome to. But it's all free there from Lucas, especially. So there. So yeah, and yeah, you definitely can view those. So
I think next time what we'll do is put a QR code for your website and our website up there, and then people can just take a quick picture of it, and then they've got that to save, and it doesn't, you don't have to go through all that typing, to get to, a
yeah,
specific site.
yeah, yeah.
Um,
So
and another one here says, when you're talking about adaptive valves and you're talking about the wrong learning and relearning and reprogramming, can you elaborate a little bit on that?
the way I like to describe it is based on fueling conditions, driving, road conditions, temperature. Can the computer get fooled in its programming the way he's trying to adapt fueling? And the answer is yes. For example, let's say he buys a bad batch of fuel and it runs rough, runs a little iffy. Maybe you can or can't feel it, but it's not very good quality fuel. That's going to change the fueling strategy. So therefore, the next tank it could be good quality diesel fuel. Or maybe this truck saw a massive rough road, like I mentioned earlier, that can also throw the programming off. So in other words, computers can learn based on certain conditions, like I said, all those different issues can actually throw the programming off. That's why these vehicles and other vehicles have had a reset strategy where you can reset it back to base programming as if it just left the assembly line. So, and that's what you're trying to do. And there's no sin in doing that either. The problem is on those very good running engines, when you reset that, you could kill that fuel economy for the customer. So he might come after you. So it kind of goes back to the saying, if it ain't broke, don't fix it, you know? So because his fuel economy could be very good. So, but if it is got an issue, yeah, it could have learned bad values. And that's based on, again, road, driving habits, fueling, and so on. And, even something as frivolous, like I've been saying over and over again, the air cleaner, did the air cleaner cause fuel adaptive strategies, carbon accumulation on the map sensor, like I said earlier. So yeah, there you go.
Okay. Another one here. When you're talking about valve lash adjustment, does the scan tool really detect that? No.
No, no,
Okay.
no. So
So
in
that
the
has,
past, so you can understand previous Duramaxes, like if I go back even to an LB7, LLY, LBZ, we have adjusted valves. And after the valve lash adjustment, all of a sudden our balancing rates are almost near perfect. And before that, they were all over the place. They were +2, +3, +4. In other words, the fueling was way out of range. And in this case, it led you to, oh, this thing's going to need injectors. And turns out that, you could hear the valve lash. And that's why for those of you that work on Duramaxes, it is a wise idea. If you're doing injectors, you better sell the customer the valve adjustment as well. So,
Okay. Very good. One more here. It says recently had a 2018 L5P that the customer was saying that having a D rate, he was having a D rate. The customer thought maybe he had a plugged DPF, and because they previously had a plugged DPF with a similar problem. So as you were saying, Tony, about an air filter, apparently the air filter was the culprit. And although I guess he'd taken it in and supposedly they changed the filter, but obviously they did not. And this was the problem. So here's a lesson in never overlook the obvious.
and what was my third or fourth slide? Diagnosis, that
Right,
strategy and that visual things you check. We've been saying that over and over. Thank you for that
right.
comment. Yes.
So one other comment or question really, in your electrical class, you were talking earlier on about back probing. In your electrical class, do you teach that? Do you have a hands-on session of
Yeah,
that?
yeah, I've been working with a company called ATEC. We've been doing some trainers. We got a whole new set of trainers and stuff that we're going to be rolling out. And in this case, yeah, some of the things we're going to be covering is back probe. So as a matter of fact, I've been making my Matco guy very rich because we've been buying a lot of back probe kits. So therefore,
Yeah,
yeah, it's something we're going to become both on a webinar and in our live classes.
very good.
So definitely check the schedule on powertrain training. I have a lot of lecture coming up here in Vegas. I got some in Windsor, Wisconsin. So therefore, and I'm trying to get I got a Texas deal going on here next month. So send me information on that and I will be more than happy to give it to you. So
Okay, one other comment here. It says again, what is the average time on valve adjustment? I think you mentioned like 70,000, right?
what is the question? How often or
Yeah, how often? What's the average time on valve adjustment?
average? We do them around 70, 80,000. General Motors recommends for severe duty 50,000 and average around 90 to 100,000 miles. So it's
Okay,
not something you periodically do like a Cummins. No,
sure,
it's not something
sure,
that's, but you should be doing. So most of the trucks we get that are hard driven, over 50. But please
sure.
keep in mind that the valve lash issue can be affected by poor maintenance, not enough oil changes. So we're not in agreement with General Motors about 10,000-mile oil change intervals. No, we need to drop that by half. So in this case, yeah, keep an eye on those oil changes. No, 10,000 doesn't cut it. So
Okay, very good. I think that about covers it, Tony. I wanted to thank you personally very much for your presentation. Extremely informative as usual. And let everybody know that we're going to have another one in February and all the months ahead. So look out for the timing and the date for our next presentation, the subject matter. Thank you very much for attending, and we look forward to seeing you next time. Take care, Tony. Bye-bye.
thank you.